Hi everyone, welcome to our group presentation for ITT632 mobile cloud computing called Shuttle UiTM BusTracking. And these are our team members, Aina, Azifah, Nurin, Mushahafizi and Izzat. For the introduction, the Shuttle UiTM BusTracking is a mobile application that is developed to improve the efficiency of the campus shuttle bus system at UiTM. So actually, the application allows students to track shuttle bus locations in real time, so they no longer need to wait without knowing where the bus is. So instead of using additional hardware or IoT devices, the system uses the driver's smartphone to share live location data. So at the beginning of the shift, the driver scans a QR code to start the tracking process. Then the live location will then be shared with the students through the application and can also be monitored by the UiTM staff. So this can help the students plan their travel better and reduce long waiting times. So this application is actually built using technologies such as Firebase, Google Maps API, QR scanning, and also user authentication to provide a reliable and easy to use solution. For this project, we have two problem statements. First is the student lack of real-time visibility of bus location, which this causes uncertain waiting time and poor travel planning. And the second problem statement is that the current bus waiting system, it relies on static or manual information, which this method is inefficient and unable to provide accurate arrival prediction. Next, the objective of this project is first to create a mobile application that lets students see the location of campus shuttle bus in real time. Second, to develop an intelligent campus shuttle tracking system specifically for UiTM students. And the third objective is to increase shuttle bus services accessibility and visibility on the UiTM campus. The scope of this project are user and application, in which the user are the UiTM Shuttle students and also UiTM Shuttle bus drivers, and the application is on real-time bus location and report submission. Next is the cloud services we use in our project. So for this project, there are several cloud computing services used to support the back-end and core features of the Shuttle UiTM BusTracking mobile application. So the first group of services is the third-party cloud computing services. First, for the authentication, we use Firebase authentication to manage the user login and identity for students, bus drivers, and also admin. This provides secure email and password authentication and assign a unique user ID that link user data across the system and enable controlled access using Firebase security rules. Next, for the database service, we use the Firebase Cloud Firestore and also Firebase Real-Time Database together. So the Cloud Firestore actually stores structured data such as user profile, report, and driver status information, while the Firebase Real-Time Database is used for real-time shuttle bus location tracking. This hybrid database approach actually improves the performance by separating live location data from structured records. And the third one we use is the Firebase Cloud Storage, which it is used to store image uploaded by user when they submit reports such as lost items or service-related issues. This provides secure and scalable storage and restrict file access based on user authentication. And lastly, we use the Google Map platform that is integrated to display live shuttle bus location on an interactive map. It provides accurate map data, map markers, and also smooth interaction for user tracking the shuttle buses. For the in-house web service, we use the Firebase in the Shuttle UiTM BusTracking. So although Firebase is a cloud-hosted platform, it is considered in-house for this project because all the back-end logic and data structure, access rules, and also service workflows are designed and managed internally by our group. So the Firebase database collections and path act as internal service endpoint that handle the user management, driver status updates, real-time tracking, and also report processing. So this makes the Firebase function as a custom backend service layer rather than a generic third-party API.
Next, this diagram illustrates the database design of our UiTM shuttle bus tracking system. So the database technology and structure, we use Firebase Firestore and Firebase Real-Time. It is a hybrid NoSQL database architecture, where the Firestore is user collection-based approach, while the real-time database uses JSON tree structure approach. And the collections from the Firestore include users, students, and drivers, buses, and reports, while the driver locations is coming from the real-time database. Next, let's move on to the system architecture. Our system architecture is designed using a mobile cloud architecture to support real-time shuttle tracking. This architecture consists of four main components: users, mobile application, internet, and cloud, while an external mapping platform like Google Maps is integrated to visualize the shuttle locations. And there are two types of user in the system, which are student and driver, where both the user will access the system through the same mobile application, but they are directed to different interfaces based on their user role. And for your information, the mobile application will communicate with cloud service through the internet, and Firebase authentication will be used to manage secure user login and role-based access control. Other than that, the driver interface will capture the real-time geographical location using the smartphone's built-in GPS sensor, and this location data will continuously transmitted to the cloud and update in real time, while the student interface will retrieve this live location data from the cloud and display it on interactive map using the Google Maps platform. So all cloud operations like authentication, real-time data synchronization, and storage are handled by the Firebase service, which act as the central backend infrastructure. Next, this slide explains the service design of our UiTM Shuttle Bus Tracking mobile application. Our system follows a service-oriented design where Firebase is used as the in-house backend platform to handle authentication, data storage, and real-time data synchronization between the users. First, for user management, we use Firebase authentication to verify users, where user profile data is stored in the user profile collection and linked using the Firebase UID. And we also implement role-based access where students can view locations and submit reports, while drivers can update bus status and their live location. While for the real-time bus tracking service, these allow drivers to share live GPS data using their smartphone. This location data is stored in the driver location collections and synchronized in real time using Firestore. When a driver ends their section, the bus is automatically removed from the student map view. While for the driver section and management, drivers start a section by scanning a QR code assigned to a specific bus. This will activate the tracking section and assign the bus and route. The driver can update the operational status such as active or break or end shift, but once the section ends, tracking will stop. Lastly, the reporting service. This allows students to submit reports such as lost item, route driver behavior, or late buses. All reports are stored in the reports collection where their status can be tracked and managed by the admin. Overall, this service design ensures a clear separation of responsibility while allowing all service to communicate efficiently through Firebase with proper access control.
So let's start with our demonstration now. So first of all, the user must register their account first, so they can put out their name, student ID, email, and password here. They also can add picture if they want. So I already create one, and this is the profile of my account. So for the image, we use storage, and the account user profile user account will stored in Firestore database and authentication. So this is the profile image. So I already create my account, and by default it will create as student. And for the driver, the admin currently need to manually change the role to driver from student. So let's start login now. So this is driver interface where they can start scan to start their shift and profile. So this is the profile where it will show the role of the driver, the account, and the user detail. So let's start our shift. So this is QR. I will scan it. So requesting location now. This is the user interface when we are broadcasting our location. So when you click the marker, we can see that the driver currently on bus working on bus D. This marker also available on the student side. So let's see it in database. So we are using a real-time database so that we can update it frequently. So this is the detail of our bus. So when I click on brake, it will change on brake. So the driver can press on brake when they are still on their shift but are currently resting for pray or lunch or anything. They can press on brake, then it will appear on student side that they are on brake. So for the coordinate, we will update the location for every 5 meter, but we can change it depending on how fast the bus are driving. The one who make policy can update the location update, so that consumption of phone battery are in good level. So when the driver shift and already end, they can press and shift to stop tracking. So they will back to the main screen, and on the drivers on the database the the bus detail will be removed, so that on the student side the marker will not appear.
Okay, now we will go to this demonstration for the student part. Like we always do for any apps, firstly we need to log in first using the email of the student, and also we need to use the password that been registered. For the registration, you can see the part for Izzat. So here is the main page that will be shown to the student, and at the home page the student will see the bus schedule. We have the bus A, bus B, bus C, and also bus D. And at the bottom, if you can see, there is a box that shows thread bus, the report, and also the profile. So if we click on the thread bus, it will show this interface, which is the Google Maps, that will show the marker of the available bus. And if we click on the marker, it will show the status of the bus, which is the driver, and also the status on duty or break. And also we have the filter at the top that can filter all the bus to show the all available bus, or you can choose if you want to see where is the bus D, or where is the bus C, or where is the bus A. And here we have only two bus, and the filter is working, as you can see. Next, we will go to the report. If we click on the report icon, it will go to this interface, which is the submit report, and you can choose which report you want to make. We have the lost item, left behind item, route driver, or late bus. Here I choose the route driver, and we can choose the which bus that we want to report. Here I put bus C, and the description I want to put the driver was yelling at me. And we also can upload a photo as evidence. Here we can choose any photo that we want, and we click on the submit report button. We wait for a while, and you can see at the bottom we have the report submitted successfully. And here is at the database, which is we use the Firestore database for the submission of the report, and we use the Firestore storage to show the image that been sent. Next, we can see the profile of our student, which is Jose. And I think that's all for the student part. We have the log button, and that's all. Thank you.
Next, I'll be presenting on limitations for this project. So, the limitation that we face in this project is that the high dependency on internet connectivity. Our real-time tracking relies heavily on stable internet access, which causing potential delays in areas with weak network coverage. A manual role management for drivers, where driver roles must be assigned manually by an administrator, which may lead to an inefficiency, delays, and human error. The absence of route optimization, where the system does not include a traffic-aware routing or dynamic route optimization, which limits the operational efficiency during the peak hours. Next, on recommendation, like I've stated before in limitation, the current implementation for role-based, especially for driver, is done manually by admin through the database system. So the first one that I will be recommending is to add a automated role assignments, implementing an automated driver verification using their staff ID, QR-based registration, or admin approval workflows. Next is on estimated time of arrival (ETA). It helps for especially on students to know and to plan their time schedule if they know the prediction of the real time speed, route distance, and also spherical traffic data of the bus that they are currently tracking. And last but not least is offline and low connectivity support, where, because I've stated before, the limitation is the real-time database really heavily rely on internet connectivity. So we think it's good to add an offline and low connectivity support, where it introduced a offline data caching to display the last known bus location, and it will synchronize the updates once the connectivity is restored. In conclusion, the UiTM Shuttle Bus Tracking mobile application successfully meets its main objective of providing students with real-time visibility of campus shuttle bus location while improving the efficiency of transportation management. By utilizing cloud-based technologies such as Firebase and Google Maps API, the system delivers an accurate location updates without the need for any additional tracking hardware. The implementation of role-based access ensures an appropriate functionalities of both students and drivers, while features such as QR code scanning and real-time data synchronization enhances the system's reliability and usability. Overall, the application demonstrates the effectiveness of using mobile cloud computing to support smarter campus transportation and improve the overall students' experience.